Okay, so now we're going to put those on the graph. I'm going to put the graph way over here because I have other stuff to do over there. So I'm going to put it way over here. And I'm going to go 0, 10, and 3, negative 17. Okay, and I'm just going to leave those there for a minute because I really don't know what to do at the mo. Okay, now if I use the second derivative at those points, at those x values, it will tell me whether it's concave up or concave down or a point of inflection. Yeah? So I'm going to do that. I'm going to go dy, I think it's d squared y dx squared, like that, is equal to, and I'll take the derivative of the first derivative, which is 12 this time, I won't make a mistake, minus 24x, yeah? So the derivative of the first derivative is the second derivative. And then I'll set that equal to 0 just for a second. Because I'm looking for, setting it equal to 0 is for finding points of inflection. Okay? Finding points of inflection. So I'll go 12x, and that gives me x minus 2. So I think there's a point of inflection at x equals 0 and x equals 2. Don't know, but I think so. And then I can put those back into the original, and I can say, okay, the points of inflection, possible points of inflection, are 0, 10, because I just put 0 in there and got 10. And 2, I should be able to do that in my head. 2 to the 4th is 16, minus 8 times 4, plus 10. So I just put 2 in for x, and I got negative 6. Okay, I think there's points of inflection there, but I have to do some testing. All right, so what I'm going to do is I'm going to test the second derivative, this. I'm going to test like crazy, okay? Because if I just test the second derivative here, like if I go dy dx squared, if I test the second derivative here at x equals 0, the second derivative at x equals 0 is, the second derivative of x equals 0 is 0. Is that right? So that tells me that nothing. It doesn't tell me concave up or concave down, does it? It tells me something, some point of concavity. When I test at 3, Three, 12 times 9 minus 24 times 3. I got 36. Definitely, hugely concave up. Agreed? So I know this thing is concave up right here. I got that going on. Okay, but this 0 is like, that's what I didn't want to happen. I don't want it to be 0 there. I knew it was going to be 0 because at that same point ended there, yeah? But now let me test on either side of here. So let's see. Is the second derivative, does it change sign? Because that's what it says it has to happen here. It says it has to change sign on either side. So by 0, I'm going to say, okay, I'm going to pick -1 and 1. And I need to do the second derivative, okay? So when I go into the second derivative and I put in -1, I'll do it on here so you can see. Second derivative, I put in something on either side of 0 because I'm dying to know what happens. So I go 12 times -1 squared minus 24 times -1. Is that okay? I got 36. And when I put 1 into the second derivative, I get -12, I reckon. Does it change sign? Yay, it changes sign on either side. Okay, so I know it's, the derivative was 0 there, and I know it changed sign on either side. So let's go to our little gig here and say, hey, where is it? Where's my, I don't have my sheet of paper. Okay, here it is. It said the derivative was equal to 0, and the second derivative was 0, and it changed on either side, positive to negative. Oh, so it's got to be one of these. Derivative is 0, second derivative is 0, and it changes on either side. So mine changes on either side, concave up to concave down. Concave up to concave down. You with me? Concave up to concave down. And then, boy, it would be nice if I could figure out where it goes through the x-axis. How do you do that? Yeah, you set y equal to 0. Now, that's a pain, because you got to set this y equal to 0, and we're not really good at solving those. But this is. Okay? So get this out, and let's do Pauly-Schmoltz. You remember it? Okay, get it out. Okay, so your calculator's out. I'm going to pause. That's a good idea.